reactant problems are just stoichiometry problems that you have to determine who your superstar is. It's not as easy to figure out because you actually have two givens. So first thing, like in all the other stoichiometry problems, we're going to balance the equation. This one appears to be a little difficult, but it really isn't. We start with the I2. We have one I on this side, so I know I need to put a 2 in front. So that makes me have two NAs here and two NAs here, which makes me have 4. So if I put a 2NA, a 2 in front of this compound, it actually balances everything else. So I have 4 S's, and then 2 times 3 is 6, and then I have 6 O's on the product side. So I'm balanced. I'm going to pop 1's in front just so I can have them when we do our ratios. Now, in a limiting reactant problem, I do what's called a BCA table, the before, how much it's going to change, and then after. So in this problem, we have 5 moles of I2. So underneath I2, I'm going to write 5 moles. And I have 7 moles of the Na2S2O3. And I don't have any moles of my products. It doesn't give me any information about them, so I don't have any. I'm going to go ahead and just draw a line between my products and my reactants. It'll just be helpful to keep those separate. So then how does it change? Well, I need to decide who my superstar is. But I'm going to show you that even if you mess up, you'll know it, and then you'll just have to start over again. So what I'm going to do is I'm going to look and go, well, I have less moles of I2, so maybe that's my superstar. So I'm going to superstar the I2. I'm going to create my fractions. So 1 over 1, I'm going to put the 1 under everybody. 2 over 1, 2 over 1, and 1 over 1. And I'm going to write his number. He's the superstar. It's all about him. So I'm going to write 5 moles. And then I'm going to work it out. And so 5 times 1 is 5 moles. 2 times 5 is 10 moles. And I instantly see I have a problem. Because before the reaction, I have 7. The change line is really how much you're going to use. Well, it's telling me I'm going to use 10. It's like if I have $7, can I buy something that costs 10 bucks? No, I can't go in the negative because the after line is we subtract on this side and we add on this side. And so I do 5 minus 5 is 0, but 7 minus 10 is a negative 3. I can't have a negative 3 moles. So I instantly see I picked the wrong superstar. So I'm just going to erase. It's going to be okay. And I'm going to start over. So that's what's kind of nice about limiting reactants is you know if you did it wrong. You end up with a negative number on your afterline, you've done it wrong. So I'm going to change that, and now I'm going to pick this as my superstar. So my fractions change. I know it's going to be 1 over 2, 2 over 2, 2 over 2, and 1 over 2. And now it's all about the 7 moles because that's my superstar. So I'm going to write 7 under everybody. You don't get to choose different numbers. It's all about, this is just like when we did regular stoichiometry, the same guy, the superstar guy. You just have an extra line on top. So now I'm going to work it out. Well, what is 1/2 times 7? Well, that's 3.5 moles. This is 7 moles. This is 7 moles. And this is 3.5 moles. Now, I haven't got to my afterline yet. I'm going to kind of draw a line underneath this because my afterline is I'm going to take my change and I'm going to subtract it on this side. I'm going to subtract it from the before. So it's 5 minus 3.5. Well, that's 1.5 moles. Your limiting reactant, which I kind of call my loser, is my 7 minus 7. That better be 0 moles because I'm going to use it all up. That's the whole idea behind limiting reactant. It's the guy you run out of first. And so now I have 0. And this side I'm going to add because I'm making this side. So 0 plus 7 is 7 moles. And 0 plus 3.5 is 3.5 moles. So then, if I look at my questions, what is the limiting reactant? Oh, that's the guy I ran out of. So that's the Na2S2O3. And then how many moles of excess reactant remains is what I have left. So I have 1.5 moles of I2. And how much product did I make? Well, I made 7 moles of sodium iodide and 3.5 moles of the sodium with the sulfur and the oxygen. I'm not sure, I have to look up that polyatomic ion name. So that's my answers for limiting reactants. You just have to follow the BCA table.